Step 1 is to read. Calvin has 12 identical rectangular tiles. He arranges the tiles to fit exactly round the edge of a shaded rectangle, as shown in the diagram below. We've got 67 centimetres here and 123 centimetres. Work out the area of the shaded rectangle. 5-mark question, worth attempting it to see how many points you can grab, even if you can't get to the end of the question. Step 2 is going to highlight the key words. So we've got 12 tiles, they are identical. So each of these tiles around here are identical. They fit exactly around the edge of the shaded rectangle as shown here. And we need the area. We need the area of the shaded rectangle. That's what we're trying to get. So what I'm actually going to do here before I come to step 3 is I'm just going to write here at the bottom because this one is what I want at the end. So I'm reminding myself that that's what I want from the question, which is a step here. Check you have answered the question. And that's how I'm going to make sure I have. There's a lot of points, lots of working, so I don't want to lose sight of that. Formula sketch. So what I'm actually going to do, topics here. Topics is area. We haven't got anything else going on here, so just area here. Right, step 4, formula or sketch. What I'm going to do is I'm going to use some algebra to state the length and the width of each of these small rectangles. So this is one of the 12 small rectangles. I'm going to call this side X and this side Y. What we have along the bottom edge here is one lot of X. This is X here. 2, 3, 4 lots of X. And one lot of Y. Altogether, that makes 123 centimetres. Then what we've got going on here is we've got 1, 2 lots of, in this case, it's X because we've turned it on our side again. So we've got 2 lots of X plus 1 lot of Y here equals 67 centimetres. Now, I couldn't see this at the beginning, but what we have created here is 2 simultaneous equations. We have some X's, some Y's, and then we've got some numbers here. So I'm actually going to add simultaneous equation up here. Now we solve them. I've got like terms here, so I'm going to subtract. I've got more X's here, so I'm going to do number 1, subtract number 2. 4X subtract 2X is 2X. 123 subtract 67. If you need to do that, use a calculator. This equals 56. In fact, it's calculator paper, so it's a good idea to use a calculator. Then I'm going to divide both sides by 2. X equals 28. Now, simultaneous equations, I'm going to substitute X into here, into 2. Actually, this makes sense here. So 2 multiplied by 28, add Y equals 67. Subtract 56 from both sides. So we've got X and Y, but that's not everything that we need. We now have the dimension of this side and the dimension of this side. But what we need is the area of this shaded space. We don't know this bit here, though. Could we work it out? We could work it out. So there are 2 ways to do it. Either we can use X plus X plus X plus X, take away Y, or what I'm going to do is work out the total area of the whole shape, and then I'm going to take, and then I'm going to look at 12 lots of the whole tile to leave my area in the middle. So multiple ways of doing this. Let me explain what I have done there. So the total area of the whole shape is this dimension multiplied by this dimension, which is the whole bit here. Total area of one tile is 28 and 11. That's my X's and Y's that I've just created. Then if I work out all of those tiles, there are 12 of them. Put that into my calculator. And then I subtract the whole shape and I take away the bits around the edges. So it's the whole shape altogether, and I take away all of those white tiles, which will give me the shaded space. And the units are centimeters squared. It's an area. So I put this on the line, 4, 5, 4, 5 centimeters squared. Check you've answered the question. Well, it was asking for the area of the shaded rectangle, which is what I've given. And I'd go back and check my workings.